Welcome back to this video lecture series on data structure and algorithms. Today our lesson is stack implementation as linked list. So we have already seen that how to implement stack using array. But there was a disadvantage of using arrays that during runtime we were not being able to shrink or grow the stack as per our own requirements. So in this video lecture using linked list we will try to overcome that disadvantage. So let's start. First, let us see the structure of the stack here. So, unlike the structure of the array, when we will be using this linked list, the structure will include a top which will have an integer type and a pointer which will again point to this node. So here, instead of making a slot or like indexed array element, we are creating nodes in terms of linked list. So this next is the pointer which will point to the next node in sequence. In this diagram we can see that the stack is 4, 6, 7, 2 and 4 is the top of the stack. So now if we implement it as linked list, then the linked list would look like this. 4 then points to 6, 6 points to 7 and 7 points to 2. 2 is the element which is at the bottom of the stack and 4 is the top of the stack. So we also have to consider the advantage and disadvantage of this linked list. So the thing is that for advantage, what we can see is the stack when implemented as linked list, it can be made to shrink or grow in runtime. But as we are using an extra pointer in order to point to the next nodes in sequence, what we are using is extra memory requirements. So that stands as a disadvantage for this linked list implementation of stack. Lastly, let us see what are the operations we'll be implementing on this stack. So the first operation is push, that will again add a data element into the stack. The next is pop, which will remove the data element from the top of the stack. We will use isEmpty function, which will check for underflow condition, that is whether any element is there in the stack or not. And lastly here we will use a function called top, which when called will return the top of the stack element. So now let's jump onto the coding part and see how we can implement it using the linked list. So I have opened my IDE and let's start coding right now. So hashtag include, and we will be first doing this stdio h. Let me just copy this thing because I'll be adding two more libraries here. So this will be standard library.h and the last one will be limits.h. So now let us first create the structure of the stack. So again struct stack, and here what we'll do, we'll take two things. One is int top and the pointer. So struct stack next. So the structure is like this. Now let us jump onto the main function of the program. Return 0. So here first we will take a node of struct stack type. So struct stack star s, and we will initialize it to null. So here when we are creating stack, we'll do it only by using the push operations. So the function will be push, and inside it the arguments will be the address of the pointer to the stack nodes and the data we want to insert. So like this, let us say we will push 4 elements onto the stack. So 2, 3 and 4, and let me change the data values here. This will be 6, let's say 9 and 3. So after we are done with push, what we want to do is we'll want to pop the top of the stack. So for this I will take first an integer I. I'll also print a message here, that is the popped item is, and I'll use the pop function here, where again I'll pass the address of the struct stack star s, and lastly print the popped element, that is percentage d, and this will be I. And lastly I would like to have the top of the stack after the pop operation. So now top of the stack is, here again we will use a function called top, and the data value will then be printed. So this will be I again. So now we will be defining these functions we have used in this main function. So first is the push. The return type will be void, so push. The arguments we have passed is struct stack double pointer, let's say s, and an integer value called data. So here first what we'll do is struct stack star temp. We will create new node here, so new node, and the argument will be the data. So before writing the rest of the part, let us first define this function here, new node. So this function will have a return type of struct stack star, and the argument will have an integer data type. So here again I'm going to make a struct stack star, let's say node, and we'll use the malloc cut, and we will use the malloc allocation here. So malloc, this will be size of struct stack. So the node is created. Now we will assign the values like node data will be the data, and node next will be null. Now coming back to here, so here the node is created. Now what we'll do is we will make this link changes. So s next will be the newly created node or the stack element, and lastly this newly created node will be the the top of the stack. And lastly we will just print a message here, that is data pushed is percentage d, and this will be data. Right, now we will define the pop function, which will have a integer return type, and the argument is struct stack star star, let's say s. So here first we will check for a condition, that is the underflow condition, and for this we will not write another explicit function. We will write the condition right away here. So if s happens to be null, then we will return int min. Otherwise, in the else condition, for this we'll have to actually take a variable here. Yeah, so here what we'll do, we'll again take a struct stack star, let's say temp, and we will store the root, or I guess this is the top of the stack. Now I will store the data element that is to be returned from this function in this I variable. So this will be temp data, and I will change the top of the stack now. So this will be star s is equal to star s next, and I will free this temp because this node is now not needed, and lastly I will return this I. So the pop function is done, and lastly we'll again have to create this top function. here, this is the function here. So for this top function, firstly the return type will be int, and inside this the argument will be this. Simply we will return, first we will actually check for one condition, that is if the underflow condition obviously. So if s is equal to star s is equal to null, then we'll again return the int min, otherwise we will return is data right away. So okay, I have this should be a single int, not a double. So this is it. So this should be the code. So now let's run it and see whether it's been done properly or not. Okay, so the output is here. You can see the messages are printed here. Data pushed first 2, then 6, then 9, then 3. Then we will perform the pop operation. 3 will be popped, and so the top of the stack should be 9, and this is printed as like this. So this is how you can implement stack as linked list, and you can operate the push and pop operations. So thank you for watching this video and staying with us. See you next time.